our USB knowledge started to accumulate. In the previous lesson, we saw how we can send 0 and 1 differential states over USB. Now we will see how we can combine these differential 0 and 1 states to form more meaningful data on USB, or more accurately, to give the bus the ability to have multiple states more than just 0 and 1. Let's take a look together on the different bus states. Again, I'm showing you here different speeds just to let you know that generating a specific state on USB may differ between different USB speeds. So just don't pay attention to the details of every single speed. Just try to understand the idea of one of them. And for simplicity, I recommend that we only focus on full speed. Before starting, I just want to say again, don't try to memorize the name of these states. Just try to understand the idea how they are generated to enrich your USB knowledge. So what are these bus states? They are simply just signals or states we can apply on the bus. And here please notice this table has no order. I just tried to order the signals in a way that you can understand the signal simply. The first signal is SE0 or single-ended 0. USB port can generate, or let's say can apply this state on the bus by simply pulling both data lines low. So in other words, just by applying 0 volt on both data lines, nothing more. So now I just want you to get the idea that we can generate or have multiple states on the bus only by changing the state of the data lines. Okay, so the second state is detached. Detached state is just exactly as same as SE0. So both data lines are pulled down. And what do we mean by detached? This simply means that no USB device is connected to this specific USB port. I'm gonna show you soon the schematic of the USB port, and you will see that both data lines D- and D+ are by default pulled down by two resistors at the end near to the host. That means if no USB device is connected to this specific USB port, both data lines will stay pulled down, and therefore we have when we have detached state, we have as same as SE0 state, so both data lines are low or are pulled down. The next state is idle. Idle means there is a device connected to this specific USB port, and to achieve the idle state in full speed devices, USB port applies simply the differential 1 state. So in other words, one data line is high and the other is low. It's not very important now to know which one is high and which one is low. We showed that in the previous lesson. As simple as this. And notice this is different, for example, for high-speed devices. But as said, let's now stay focusing on full-speed devices. The next state is the J state, or I'm gonna mention this combined with the K state. So the next two states are J and K. These two states, the J and K states, are the major states used to transmit data over the bus. And they are called K and J because, as we can see here, or as we saw also before in the previous lesson when we talked about the differential states, the electrical state may differ between the different USB speeds. And therefore, to standardize the terms used for data transmission and to stay abstract away from the different electrical states, USB developers decided to use the terms K and J to represent two differential states on the bus. So these J and K are just names for the differential 0 and 1, because differential 1, because again, as we saw before, the electrical state to achieve differential 1 is different in full speed devices than in low speed devices. And to get rid of this, we just use J state and K state. So J for the full speed devices is just the differential state 1, and K is the opposite of J. So it's differential 0 for full speed devices. Don't get confused, this is very, very simple. We are just applying different voltages, or let's say different logical states on every single line of the data lines. And by this we are getting different states. That's it. And here I want to mention, because when we talked about the detached state, I mentioned that both data lines are by default pulled down at the end near to the host. But when we connect a USB device to a specific USB port, this USB device has one of the data lines pulled up, and which data line, if it is D plus or D minus, depends on the speed of the device. We will see that later. I just wanted to mention this to let you know why in the idle state the data lines are no more pulled down, or at least one of them is not anymore pulled down. This is just because one of the data lines at the end at the USB device is pulled up. We don't care now if it is D minus or D plus. Just you need to know now that one of the data lines is pulled up. And by this we can distinguish between the detached state when no device is connected and the idle state when a device is connected. Okay, so the next state now is SE1, single-ended one. And simply no USB developer or engineer should see this state on the bus. This is forbidden. So in this case, both data lines are pulled up or are high, and this should not be seen on USB at all. That's it. The next state is reset state. Reset state means simply that the host is telling the device that it should restart itself. Very simple. And this state can be achieved when the host applies the state SE0 for more than or for longer than 10 milliseconds. So the host pulls both data lines down for more than 10 milliseconds, and by doing this the device will be notified, or will see, let's say will see that both lines are pulled or were pulled down by the host, and it should be restarting itself. As simple as this. The next state is suspend. The USB device can read this state, or let's say you will understand that it should change its state to suspended when the bus is idle for longer than 3 milliseconds. So in other words, if no data were transmitted in the last 3 milliseconds, the USB device will know, okay, I should be suspended now. And this is mainly just to save power. The next state is resume state. And you probably noticed resume state is just to resume the device from the suspend state. And resume state can be achieved by applying a K state on the bus for more than 20 milliseconds and then followed by end of packet state. We will see this state in a minute. The next state is sync state, or it's also called start of packet, SOP. So sync or SOP signal is just a sequence of KJ, 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 K, K signals. And that's good that we said this term, packet. I'm happy that we mentioned this term, because packet is the major entity we will be dealing with as firmware engineers. Basically, when we want to send data over USB, USB port sends at first start of packet or sync signal, then it starts sending the data we want to send, represented of course in form of K and J signals, and at the end of a packet it sends end of packet signal or EOP. Don't worry about the packet term. we will be talking for a long time and a lot more about this very soon, because this is very crucial and essential for us as firmware engineers.